Good morning. Please let me know if you have any questions before I start the experiment. We have two experiments today, experiment 10 and experiment 11. But first, I'm going to open the lab manual to share with you. Second, I will answer your questions. Then we start with experiment 10. Gasless. Okay. Did you post any questions? Let me see. Last question, sure. And the pre-lab 11, sure, I will. Okay. I could not open some of the files. I don't know. Okay. But that is the question. I will go over. Sure. Let's start with experiment 10 first, unless you have question from experiment 9 or any concerns. One thing I noticed, like bringing the videos from Blackboard Collaborate into YouTube, that chat option is not there. So anything that was in the chat area, it's lost. I don't have access to it. And sometimes I type the numbers in the chat area, which made it easier for you to record. At this point, you have to just watch the video more carefully, because I also repeat. And if there was something that it's not in the video, and if you watch it, like you go back and forth a couple times, if you didn't hear, or it's like impossible to get it from video, then let me know. Because for 1046, I got email that we cannot get the data. And when I watched the video, it was actually saying every number that was recorded. So I just want to make sure you watch the video first for the data before you panic. Okay, we are doing part B of the experiment 10, which is determining molar mass, right? Determining molar mass of unknown liquid using the gas laws. So for part B of the experiment 10, we'll just determining molar mass of volatile liquid. We are using ideal gas law. Ideal gas law, it's gas laws is basically, it shows the relationship between pressure, volume, temperature, and number of moles, or the quantity of the gas. When we are using ideal gas law, for ideal gas law, you have to make sure that you use units that does match with the units of R. So if the unit for R value, the constant, is liter atmosphere per mole per Kelvin, so we have to make sure when you are using the volume in this formula is going to be in liters, pressure must be in ATM. So you can't use torr or millimeter mercury or Pascal or any other unit for pressure. You have to use ATM. So if the pressure is given in any other unit, you have to change that to ATM. If the volume is given in milliliter or cubic meter, whatever, you have to change that to liter. And temperature must always be in Kelvin for gas laws, and N is number of moles. So we have based on the reason we have to have those units is because we have to make sure that it does match with the units of our value. The way we are approaching determining the molar mass for the compound, if you have the mass, so basically you have the number of moles equals mass over molar mass. So if you find the number of moles and you have the mass of the vapor, you can find the you can then find the from that you can find the molar mass. So you're using the ideal gas law to find number of moles. So in order to find number of moles, we need the pressure, volume, temperature, value for R is given, and you find number of moles. When you have number of moles, you also need to measure the mass of the gas. When you have the mass of the gas and you have the number of moles, you can find the molar mass. Now, my questions for you. Based on the procedure, and let me call names because I haven't done this for a while. My question for you is, based on the procedure, how do you measure pressure? What is recorded as pressure for the gas? Is the pressure a given value, or how is measured? And let's see if we had someone who answered. Okay. Millimeter mercury, but what pressure? How do you measure it? Based on the procedure. Because you read the procedure, right? You read the procedure before. The pressure of the vapor, how do you measure it? What equipment are you using to measure it? Any other response? Sahar, Sonia, Ashley, Leah? What do you record for pressure? How do you measure the pressure? Because we need the pressure, we need the volume, we need temperature. A chart for the pressure? No, we are not using vapor pressure here. We are using pressure of the gas. Vapor pressure is in a closed container. This is the pressure of the gas. Okay, when you have one equation, which is PV equals nRT, you can have only one unknown, one missing value, and that one missing value based on the equation number 2 on page 135 is the N. We need to calculate N. We do not have the N because it's unknown. We have the mass, but we don't have the molar mass, so we cannot calculate N. So N in PV equals nRT is your unknown. Everything else must be determined experimentally. or must be given. It must be a constant number, a given number, or you have to measure in the lab. That's why you are in the lab trying to measure everything else in order to find value for N. So pressure must be either measured or must be recorded. So what are you using? What are you using for pressure in that page 135, equation 2? You need the value for P, which is pressure. How do you measure that? What do you record for it? So I'm gonna go for the first 5 of you to find that and tell me. You can look at the lab manual, look for the procedure, or find it. Next item, we need to find also we need to record the temperature. Caitlin, Jennifer, Garrett, and Carmen, can you tell me how do you measure temperature, or what you measure temperature for in that formula? Okay, what is measured? You are using thermometer to measure it, and you express it in, then you convert to Kelvin. That is right. But what are you measuring? What is temperature? You are measuring what to record as a temperature? You are measuring the temperature of the air. You are measuring temperature of the gas inside the flask. What are you measuring as the temperature? Please make sure that it does match with what's in the procedure. Are you measuring the temperature of the gas directly, or you are measuring the temperature of something else? And if you are measuring the temperature of the gas, are you placing the thermometer inside the flask, because that's where you have the gas. The gas will be in the flask. Caden, temperature of the water bath once the liquid in flask and the vapor escapes. Okay, very good. That is correct. You are measuring temperature of the water bath, hot water bath, and you record that temperature as temperature of the gas. Is that a good assumption? Can you make that assumption that temperature inside the flask and outside of the flask is the same? Because apparently, if you have looked at the setup, okay, you are measuring the temperature inside this liquid here. That is the temperature of the water, hot water. And you assume that is equal to temperature of the gas inside the flask. Is that a good assumption? Is it valid? And under what condition you can make that assumption? As long as you don't heat up the water too fast, okay, that makes sense. Or another way to say it, if you leave the flask for a long time, like maybe at least like 3 to 5 minutes inside the hot water, and you give enough time, the temperature inside the flask and outside of the flask is going to exchange, and it reaches equilibrium, and at the end it would reach to the same number. Because if the water outside of the flask is hot, the air inside the flask is cold, the heat from outside is going to move into the flask, and is going to, when the heat from outside of the flask moves into the flask, inside the flask, is going to heat up the gas inside the flask. So far, we only have the temperature. How do you measure pressure? So everybody's clear what we are measuring for temperature and why we are assuming that is correct. We measure the temperature of the hot water, or the water bath, or boiling water, or as soon as the vapor escapes. At that point, you record the temperature, and you record that as same as temperature of the gas. Okay, did you look for pressure? How do you find the pressure? What do you record for pressure? And then Danielle, Davis, Sroti, Katie, tell me, what do you use? How do you measure the volume? How do you measure the volume for the flask? Davis, I'm sure it should say something to record the temperature, the pressure. It should say something. Pressure at any time, or the instructor, okay, or the instructor will provide the pressure. So if the instructor provides the pressure, that pressure measures the atmospheric pressure at any time, right? Atmospheric pressure. And so we are making another assumption, right? We are making assumption. What is the assumption? The assumption is that the atmospheric pressure, so basically the pressure here is equal to the pressure inside the flask. Is that a good assumption? Or under what condition I can make that assumption? What happens if the pressure inside the flask is higher than outside of the flask? What will happen? What causes pressure? Is the gas laws covered in lecture already or no? Yes? Okay, very good. So what causes the pressure? What causes pressure of a gas? The vapor in the flask. Or if you lower the volume, the pressure goes up because the area is going to be reduced, and pressure is force over area. That force is coming from molecules that are in the container. Now, what happens if the pressure inside the flask is higher than the pressure outside of the flask? It will escape through the pinhole. Very good. That is the whole point of this. Okay. There is the pinhole on the aluminum that covers the flask based on the setup. When you make that pinhole, the only purpose of that pinhole is to make sure the pressure inside the flask equals the pressure outside the flask. So when your instructor provides the atmospheric pressure to you, the atmospheric pressure is going to be whatever. If the number is not in the video, you can use 760 millimeter mercury. But if you find it the exact number that day, you could use that. So when the pressure is higher inside, as the vapor is produced, when the liquid changes to gas, too much vapor, and is going to increase the pressure inside. But since there is a hole, pinhole there, vapor escapes. And how much of the vapor is going to escape? Until there is same pressure inside the flask and outside of the flask. What happens if the pressure outside is more? Then more molecules would go through that pinhole inside. But in this case, since we have bulk of liquid inside the flask, the pressure is going to be higher inside the flask at the beginning as you increase the temperature, and then extra vapor would go out until the pressure is equal. Okay, so you now have to measure the temperature. You now have to measure because you told me that this chapter has been covered in lecture. So you already know PV equals nRT. And if they give you word problems, you would solve it. When you work in the lab, you have to understand each one of these. You can only have one unknown, which is the number of moles at the beginning. So in order to solve for number of moles, you must experimentally find the pressure, you must experimentally find the temperature, and you must find the volume experimentally. R value is universal constant. It will be always provided. It's a constant number, so you don't have to find it. Someone else did find it for you. But the volume, you have to find the volume. I did ask few people already. I'm waiting for that answer. Tell me, how do you measure the volume? What do you record as volume? And how do you measure it? Danielle, Davis, Suroti, Kate, and Bianca. Any of you can answer that. Okay, what do you record? That flask, let's say, is a 125 flask. Do you record 125? Is labeled as a 125 flask. Okay. After you clean the flask, you pour enough water to fill the flask completely, and you have to keep track of how much water it takes to fill up the flask. Okay. I expect everyone in class to answer the questions. I'm going to record like how many questions are answered by each person. Just make sure that you do participate. And I know it's the remote, but still these are important. You know, it's different from solving the problem in lecture. So you could be very good at doing the math part, but in the lab is more of a technique, trying to figure out how to measure the volume. But that's not the only way that you could measure the volume. Use a 200 milliliter flask and pour the water from the flask. So you could go either way, right? Either way. So you can do fill up the flask all the way and then transfer into the graduate cylinder, or you start with 200 milliliter flask filled up with water to the mark of 200 and pour into the flask and see how much water it takes to fill up the flask and how much is going to be left in the graduate cylinder. Let's say if only 30 milliliters is left, then we know 170 has been consumed to fill up the flask. Okay, very good. So when you have the volume, temperature, and pressure measured, you can calculate number of moles. Okay, I have last group. Manisha, Jada, Sierra, Javier. Can you tell me how do you measure the mass of the vapor? What procedure is used to measure the mass of the vapor? Because we need the mass of the vapor in order to find the molar mass. That's equation number 3 on page 135. Number of moles is calculated for that equation. Molar mass is your unknown. You have to measure the mass of the vapor. How do you measure the mass of vapor? I hope you read the procedure already. If not, you can read it now. Give me the answer because I'm not going to give you the answer. I'm waiting for that answer. We don't have the molar mass. Molar mass is unknown. This experiment is performed to determine the molar mass. And since we don't have the molar mass, we cannot use that formula. We can use that formula to calculate the molar mass, which is the mass divided by number of moles. But in order to calculate molar mass, we need the mass. How do you measure the mass? Subtracting the differences of the flask. Okay. Could you refer to two specific steps, please? before adding the liquid, which is the empty flask, and after adding liquid? Are we using the mass of the liquid? No, we don't use mass of liquid. We need the mass of vapor, right? So when do you measure the mass again? So one is before adding liquid, empty flask. Second, you heat up the liquid and it changes to the vapor. When extra vapor escapes, or just as soon as you bring out of the hot water, you dry outside of the flask and you measure the mass after it's evaporated. When it's evaporated, then some vapor still is in the flask. When you take it out of the flask, out of the hot water, you dry the outside of the flask, and then you are going to measure the mass right away. After the liquid evaporates, when you take it out of the hot water, you dry outside. Make sure there is no water trapped under the aluminum foil. You measure the mass at that point. And then density cannot be used. Density cannot be used to measure the mass because we don't have the density of the gas. Density of the gas is an unknown gas. This is an unknown compound. If we had a known density of water, no. Gas, the density of the, if you were using density, you should use the density of the gas, not the water, because you're not trying to find a mass for water, you're trying to find a mass for gas. So you need density for the gas, and we don't have it. Why we don't have it? Because it's the unknown gas, it's the unknown compound. So you would use the mass. The procedure tells you to measure the mass of the flask before, measure the mass of the flask after you evaporate or remove it from the hot water, and to subtract, you get the mass of the vapor. Okay. It's just two simple formulas. After, if you understand how to get these numbers, then it's just a simple formula. Make sure you show your calculation and you make sure that you use the proper unit. You have to watch the video a little bit more carefully because the chat option is not there. And if the chat option is there, you let me know so I don't have to be worried about it. Because on my view, it doesn't show the chat option in YouTube. Do you see the chat or what's recorded in chat area when you watch the video? No? Okay, then you just have to watch it more carefully, listen, and yeah, Blackboard Collaborate, but Blackboard Collaborate is not available anymore. Okay, next experiment, molar mass of a soluble substance by using freezing point depression. Basically is a colligative property. Using colligative properties. Colligative properties, those are properties that depends on number of particles. Freezing point depression, boiling point elevation, change in osmotic pressure, change in viscosity. I mean, these are colligative properties. So the fact that change in freezing point, it depends on number of particles, or depends on number of moles or molality of the substance in the solvent. We can use that fact and determine the molar mass of the compound. So this diagram, what this diagram shows is that this diagram shows your change in freezing point and change in the boiling point. So we have when we have a solution would show this dashed line phase diagram, okay, using the dashed line. The solid line is your solvent. When you add a solute, you change the solution. Let's say you have water and you add salt to it. When you add salt to it, freezing point is going to be lower. That's why to make like ice cream, you add salt to ice to lower the temperature, or to melt the ice on the street, they add salt. So boiling point is going to be higher. So we have boiling point elevation, freezing point depression. That is known as colligative property. Now, that freezing point depression, it depends on the concentration. And we can use that concentration factor in order to find molar mass again. Okay, so we have two steps. So delta TF, this is change in freezing point, equals KF. KF is a constant value, and KF, does KF depends on the solvent or the unknown compound that you're adding? KF is specified for what? Is the known value for the solvent. Okay? Is the known value for the solvent. So for the for benzophenone, this value is 9.8 degrees Celsius per mole. So if the KF is known value, because we know what solvent we are using, delta TF needs to be determined experimentally. Anyone who has not answered the question? Lillian, Aisha, Jada, Bianca. If you have not answered, which I think, I don't remember you answering the questions yet, can you tell me how do you find the value for delta TF? Based on the procedure, how do you find the value for delta TF? What is delta TF? Ashley, have you answered any questions? Okay, if it says freezing point depression, sure, it's a freezing point depression. My question is, experimentally, how do you find that number? Because you need to, in the lab, it's not given number. You have to find that value. So first, okay, first you are going to find the freezing point of the solvent. Basically, you have to melt the solvent to high temperature and then lower the temperature as you're monitoring the temperature until the temperature stays constant and the compound changes to solid, and you record that temperature as the freezing point for pure solid. Then you add your unknown compound to it. You heat up again, you change it to liquid, you lower the temperature until it freezes again, and you record the temperature for solution. The difference in the freezing point is called delta TF, or the freezing point depression. Value for KF is given. From that, you can find molality. Molality is moles of solute per kilogram of solvent. Okay? Moles of solute per kilogram of solvent. So you can find the number of moles, because kilogram of the solvent, if you use 10 gram, that would be 0.001 gram. If you use like a 15 gram, it would be 0.015 gram, right? So you have you have the values for the solvent or mass of the solvent. You just have to change that to kilogram. If you have the molality already from equation 4, then you can find number of moles. If you have number of moles, you have the mass of the solute, you can find the molar mass of solute. So it's kind of the last part is just like experiment 10. You have the mass, you have number of moles, you can find the molar mass. Okay, the triple point is right here. That means that when you go from, you see, you have to read the graph. You're increasing the pressure, you're increasing the temperature. As you increase the temperature, you start with the solid here. If you increase the temperature, it goes to liquid, and if you further increase, it's going to go to gas. So when you have these lines, this area here, it's solid. Down here you have gas, and up here you have liquid. This point, triple point, is when all three phases they coexist. If you increase the temperature slightly, it can go from liquid to gas, or from solid to liquid, or decrease it, it would go back. Okay, so if you increase the temperature, it will go more toward the liquid and then the solid. If you decrease it, it will go back to the solid part. But under this condition, that means you have this pressure. Oops, if it does. That's the pressure line. And then you have this temperature. So between this temperature and that pressure, you have the triple point. That means all three of them they coexist. So it depends on, at any given point here, you can find a temperature and pressure, and then if the pressure and temperature is like corresponds here, we know that sample is in liquid phase. So if it goes to temperature here, and the pressure is all the way down here, then we know that is in the gas phase. I don't know what else you want me to explain about this graph. And if you ask me, I can. If I already answered your question, that's also good. Okay. So you're going to increase the temperature. So first, find the melting point for solvent. Then you find the melting point for the solution. You find your delta T. When you have the delta T, you can find the M value, molality, because Kf is given. And when you have the molality, use the formula to find the mass. You have the mass, you have the number of moles, you find the molar mass. And there was a question about the pre-lab that someone asked. Okay, gram of sample benzophenone. So what is this value here? 10.1. What is that? Is that mass of the solute, or is it mass of the solvent? Because you need the mass of solute and you need the mass of solvent. Okay, very good. So you have the mass, oh no, that's the mass of your solvent. Okay, so that's the mass of solvent. And what is 46.8? That's the freezing point. Is that the freezing point of solvent, or is the freezing point of solution? freezing point of the solvent. So you have the mass of solvent, you have freezing point of solvent, okay? You have 0.68 grams of the unknown. This is the mass of solute. Just write down, okay? This is mass of solute. Are added to this mass. Now the freezing point of 42.6. What is this freezing point? 42.6 is freezing point of solvent or solution? Freezing point of solution. Okay, very good. So you subtract the 46.8 minus the 42.6. That would be your delta TF. So when you have delta TF, you also have a KF value. That will give you the value for molality, right? When you have the molality, you find the number of moles. How do you find number of moles? Molality and number of moles, use this formula. So because I cannot write here, I'm gonna just take you to this formula and tell you what formula to use. Okay, so from equation 4, you find the lowercase m, which is called molality, right? Molality. And then if you have the molality, you can find moles of the solute because you have the kilogram of solvent. That's going to be the 0.01 kilogram of the solvent that we had. When you have the moles of solute, you have mass of the solute. Mass divided by moles of solute, that would give you the molar mass for your unknown. Okay, can you see this? Can you see it? Okay. So you have molality is number of moles over kilogram solvent. The kilogram solvent was given in the problem, which is a point, it was a 0.01 something, right? 109, I think it was. Was it 10.9 or 10.1? Let me go. Problem. Now that you ask, let me just at least show you. Okay, 10.1. So it's 101.8. So you have that value. But you need the molality. Molality, you should calculate down here and bring it up to put in this equation. To find the molality, you need the KF. The KF value is 9.8. And delta T here is a 46.8 minus 42.6. So you find the difference, that's delta TF. And then kilogram of, KF value is 9.8. You find the molality. When you find the molality, you bring it up to this equation. And in this equation, you have the kilogram of solvent, you have the molality, then you find number of moles. So number of moles would be molality times kilogram of solvent. When you have number of moles, you can find the molar mass. Molar mass then is mass divide by number of moles. Okay. So you have to do 1, 2, 3. Okay, perfect. And then for the mass, we already know that it was about 0.6 gram. I don't know the exact, I don't remember the exact number, but it's about 0.6 gram. Best thing for you to label each number that is given to you. So if as you read the problem, you say, okay, the 10.1 gram, what is that? Is that mass of solvent or solute? Because you need the mass of solvent, you need the mass of solute for these 3 steps. So for these 3 formulas, see, you need the delta TF, that means freezing point for solute, I'm sorry, solvent, and freezing point for solution. The difference is delta TF. KF is constant number, it will be given. And then you need the mass for the solute, you need the mass for solvent. So if you label your data as given the problem, it's going to help you a lot with setting up the problem. And to set up the problems, you just go with the steps that I numbered on the side. Okay? We go 1, 2, and then 3. Okay, any other questions you might have? No questions? Okay, perfect. Let me see if the assignment is open, you can resubmit it. If it's already closed, then it was the yes, it still is open. You can resubmit it. Okay. Good. Yeah, if the assignment for pre-lab is still open, is only open for today, so you can resubmit. Okay. Any other questions you might have for me? No questions? If you answered question and I remember, I'm just going to put you present. So if I didn't call your name, that means that I remember you answering questions. Others, I have to check the chat. Sahar? Thank you. Sonia? Correct? Danielle? Carmen? Jada? Jada? Sierra? Lillian? Lillian? Lillian is not here. Aisha? Matthew, did you have problem with your internet today? Okay. Very good. Thank you. And have a nice day. 2 more experiments. 12 and 13. Davis, you answered many questions. That's why I didn't call your name. If I didn't call your name, that means I remembered you answered. Yes. Jennifer, same. Hannah, yes, the same. Yes. And others might have answered question, I just didn't remember it.
Professor?
Yes.
Yeah, this is Shruti. You had texted me through the chat and told me you couldn't open any of my assignments. So,
How are you saving them?
Sorry?
How are you saving them? Are they aren't they PDF?
Yeah, so I just downloaded off the like D2L, and then because in the beginning, remember, I used to like write it out on a piece, like I used to print it out and then write it out and then submit to you a picture of it. But then
Do you
told
have like is a Word document? Is it like updated Word or something? I don't know why it doesn't allow me to open it. And since it doesn't allow me to open it, I think the best way for you is to get tell me to
Should I like
save as
sorry?
PDF and submit.
Okay, so for all the old assignments, because I just checked the grades, for a lot of them, you said that you couldn't open them. So for all of those, should I resubmit it to you in the PDF version?
Yes.
And since they're not open, so should I send it through email?
No, it has to go to the same document, same folder. So for that, you have to get me first. You have to prepare them and then send me an email and submit. Okay, just the ones that you have submitted already. Okay, for the regrade, submit them to the lab report for experiment 10.
For which ones?
The data sheet for experiment 10.
Okay, so just that one we haven't. Okay.
I know. So you have.
Sorry.
It's open. That's why I'm saying, because that one is open.
Yeah. So experiment 10 data sheet is next week's assignment, though, right? So you're saying to submit that as a PDF. Okay.
But it's open today. You submit it as a PDF into that folder.
Okay, okay, I get it. Okay.
Yes, the resubmission, you submit it into that folder.
Okay. And then I'll send you an email. So it might take me a little bit of time because I don't have a PDF converter, so I have to go buy one. It might take me.
What is that you have to buy? You can save it as PDF or print as PDF. You don't have to buy it.
You can say I can't save it as a PDF. If it's from Word, I can't save it as a PDF. I can screenshot it.
Word has that option. You just go no screenshots. No, you go file and then it says save as PDF.
Okay.
Yeah, print PDF. No, you don't have to buy it. As VC students, you can call the help desk. They can help you.
Okay. Thank you so much. I'll send you an email once I have everything ready.
Okay, perfect.
Thank you.
So,